Welcome, chemistry students. We are going to discuss this week's focus, which is dilution. So dilution is when we lower the concentration of a solution by adding, what do you think we're going to add to lower concentration? If you thought solvent, you were correct. So solvent in most cases is going to be water. So here I have a 1 liter solution with 2 moles, so that tells me the number of solute. Okay, so this is 2 moles of solute here. Now, as I add more water, is that going to increase the amount of solute present? If you watched the last video, you know the answer to this. Okay, so as I pour in water, I don't change the amount of solute, but I do change the amount of solvent so that the solution is now 2 liters. What I have just done is if I calculated the molarity before, I would take 2 divided by 1 moles over liters equals a 2 molar solution before. Now, if you look at after, you take the 2 moles of solute because that doesn't change when I add solvent. And I'm going to divide it by the new volume of 2 liters. And that will give me a 1 molar solution after. So by increasing the amount of solvent, I can decrease the concentration, which is called diluting. We're going to learn how to do specific calculations using this equation right here. M1V1 equals M2V2. Now, when you have something before, so the solution that you start with is M1V1. And then the diluted or lower concentration solution is M2V2, 2 being second. Okay? Now, there are 2 ways we can use this equation. First, we can create a new solution with a specific concentration. In this case, we will be solving for V2 because we know the concentration we want out and we need to find out how much the volume will be. Or we might know the volume we want and the concentration we want, and we might want to know how much volume of another solution we need to start with. So in either case, when we know the specific concentration we want out, we will be solving for volume, which is always going to be in liters. Now, in other cases, we might know the new concentration of a specific, or we might need to know the new concentration of a specific volume. In that case, we will be looking for M2 because we already know the volume, or V2, that we have. Now I'm going to go through 2 examples. Follow along with me, please. Example number 1. I need 2 liters of a 3 molar sodium chloride solution. AQ, we haven't seen this in a while, means aqueous. Number 2, I have a 6 molar sodium chloride solution. So if we look at this, we have a lower or diluted solution that we need, and we have a 6 molar or concentrated solution that we are starting with. Either way, the first thing we need to do is figure out where our information fits in with our equation. So M1V1 is what we start with, and M2V2 is what we end with. I know that what I need is going to be what I end with. So I'm going to start with 2 liters. So I'm going to put my 2 here under the volume. And then I know I also need, so it's going to be my second solution, 3 molar. So we put the 3 here. We set this equal. And now we know that we will have a 6 molar solution. This is what I start with. And then what we'll be actually looking for will be this piece of information right here. This is going to tell me how much of the concentrated solution I need to start with. And that'll be what I will add the actual water to. So we're going to start here by taking our 6 times V1 equals 3 times 2 and solve from there. You can start by multiplying these numbers together, so you should get 6V1 equals 6. And then you're going to divide both sides by the number that is next to the variable, so you can get the variable alone. So you should get 6 here and 6 here. These will cancel out, and you need to plug in 6 divided by 6 into your calculator, and that will get you an answer of 1 liter equals volume 1. What this information tells me is that if I have a beaker with 1 liter of a 6 molar solution, I have enough solute particles to make what I need. But if I went back to my other slide, I would notice that I actually need 2 liters. So to get from my starting volume to my ending volume, I'm going to need to add water. And the question is, how much water do I add? I do that by taking volume 2 and subtracting volume 1. So the volume that I already am going to add, I subtract out here, and that's going to tell me how much water I need to get to this number. So this is going to be 2 liters minus 1 liter, which equals 1 liter of water that we need to add in order to get to our 2 liters of total volume. So I'd take my 1 liter here that I start with of my 6 molar solution. So this is the very concentrated solution, and I'm going to dilute it, and I'm going to add another liter until it reaches the 2 liter mark. So my final answer is that I need 1 liter of the concentrated solution, and I need to add 1 liter of water to dilute. So there are 2 different parts of my answer. How much of the concentrated solution do I need, and how much of the water do I need to add to dilute it? Alright, that's the end of example 1. You can pause and try some practice problems, or you can go on and watch example 2. Alright, you are 2/3 of the way through this video. We are going to start now on example 2. So in example 2, I have 1 liter of 12 molar hydrochloric acid. This is my concentrated solution. So this is the solution I'm going to dilute. And in this case, I took my 1 liter and I added 500 milliliters, and I should have written of water to that solution. And what I need to find is I need to find the new concentration. Our first step for solving this is going to be to convert anything that's in milliliters to liters. So the way I do that is I take 500 milliliters, I multiply by a line, and I write equals liters. I put the units that I need on top and the units I already know on bottom. And then I'm going to go to my sheet in my notebook that has all our conversion factors, and I'm going to find that 1 liter has 1,000 milliliters. I can also rewrite this and say 500 divided by 1,000. That would be the exact same thing as mathematically as this. And that's going to give me an answer of 0.5 liters. So what I'm saying here is that I am taking a beaker that has 1 liter in it, and I'm adding another half a liter because 1/2 equals 0.5. And by adding that half a liter of water, it's going to allow these solute particles to spread out more, which is going to lower the concentration. So what we need to do in order to find that new concentration is find that final volume that our solute particles can spread out in. So what we do there is we find the first volume, and then we add it to any added volume, and that will equal our final volume. Final volume can also be written in our equation as V2. So in this case, I'm going to take 1 plus 0.5 equals 1.5 liters is V2. Now that I know all of my information, I can just plug in. So I started with a 12 molar solution that is 1 liter in volume. And the final volume I've calculated to be 1.5 liters. What I need to solve for is how concentrated that is when it's at 1.5 liters. So I'm going to start off by multiplying these two things together, which will just be 12 equals M2 times 1.5. And then what I need to do is I need to divide to get M2 by itself. So we're going to take 12 divided by 1.5, and this side divide by 1.5. These cancel because we have the same thing on top and bottom. And when we plug that into our calculator, we will get 8 equals M2. So my final answer is that the final concentration of the solution is 8 molar. All right, you can go and do some practice problems. Thanks for listening.